Hello and welcome back to the BEEiLab channel. Today, we're diving into matrix computing with the NumPy library in Python. NumPy is a fundamental package for scientific computing, providing support for large, multi-dimensional arrays and matrices, along with mathematical functions to operate on these arrays. Before we get started, make sure you have NumPy installed. You can install NumPy using pip install NumPy. However, if you're using Anaconda with Jupyter Notebook, NumPy is already installed, and there is no need to install it separately. So, let's begin our journey. In the first step, we import the NumPy library and give it the alias NP. This is a common convention for brevity when working with NumPy. Now that we imported NumPy, we will learn how to create an array using NumPy. First, we create a one-dimensional array named arr_1d using the np.array function. In this case, the array contains the elements 1, 2, and 3. Next, we create a two-dimensional array arr_2d. This array has 2 rows and 3 columns, forming a matrix. Each row is an array within the larger array. And finally, we used a similar approach to create a 3-dimensional array. It's essentially a collection of 2D arrays. Each of the 2 outer elements is a 2 by 2 matrix. This represents a higher dimensional structure useful in various scientific and computational applications. Moving on to another fundamental aspect of NumPy, we shift our focus to array shape and reshaping capabilities. In the provided code snippet, an initial 2-dimensional array, ARR, is defined with 2 rows and 3 columns. To grasp the structure of this array, we utilize shape equals arr.shape, revealing that our array has a shape of 2 and 3. Continuing, we witness the versatility of reshaping arrays with the line reshaped_arr equals arr.reshape 3 and 2. This operation transforms the original array into a new shape, specifically a matrix with 3 rows and 2 columns. NumPy has a great capability to generate random numbers. In this code snippet, we initialize a 3 by 3 array, random_array, filled with random values between 0 and 1 using np.random.ran3 and 3. This feature is particularly useful in scenarios where random data is required, such as in simulations or random sampling. Next, we employ np.random.randint1 and 10 to generate a single random integer between 1 and 10, stored in the variable random_int. This functionality is valuable for scenarios where a controlled yet random input is needed. As we delve deeper into NumPy's capabilities, our focus turns to mathematical and statistical operations. In this code snippet, we work with a simple array, ARR, containing values 1, 2, 3, 4, and 5. The line mean_value equals np.mean_arr calculates the mean value of the array, providing a measure of central tendency. Meanwhile, median_value equals np.median_arr computes the median, showcasing the middle value in a sorted list of numbers. Additionally, std_deviation equals np.stdarr calculates the standard deviation, offering insights into the spread or dispersion of the data. Moreover, we calculate the min and max of the ARR using np.min and np.max respectively. In the next section, we generate 2 random standard normal matrices in NumPy. In the provided code snippet, 2 matrices, A and B, each with a shape of 2, 3, are created using np.random.standard_normal2 and 3. To combine these matrices vertically, we employ V equals np.stack A and B, forming a new matrix V by stacking A above B. Conversely, for horizontal stacking, we use H equals np.stack A and B, resulting in a matrix H with A and B side by side. Next, we focus on creating and transposing a 2D array using NumPy. In the provided code snippet, the 2D array ARR is initialized with values 1, 2, 3, 4, 5, and 6 using the np.array. To gain insights into the original structure, we print the array. The next step involves transposing the array using transpose_arr equals arr.transpose. The transposition operation swaps the rows and columns, creating a new array named transpose_arr. For clarity, we print the transposed array. In NumPy, indexing provides a powerful mechanism to access, modify, and extract subsets of arrays. Consider a 1D array, ARR_1D, where individual elements can be accessed by their index. For example, ARR_1D0 retrieves the first element, and ARR_1D2 retrieves the third element. Slicing, achieved through expressions like ARR_1D 1:4, allows for the extraction of a subset of the array, providing flexibility in data manipulation. Indexing also facilitates the modification of array elements. For instance, ARR_1D2 is equal to 10 modifies the value at index 2 to be 10, showcasing the array's mutability. Now what happens if we have a 2D array? In this case, indexing allows for accessing individual elements using row and column indices. In the expression ARR_2D1 and 2, we retrieve the element in the second row and third column. Slicing operations, like ARR_2D1 and colon for the second row or ARR_2D colon and 0 for the first column, provide a versatile way to extract specific portions of the 2D array. Moreover, conditional indexing introduces a powerful feature, enabling the selection of elements based on a specified condition. For instance, ARR_2D ARR_2D greater than 5 returns an array containing elements greater than 5. This technique is valuable in scenarios where specific data points need to be identified based on certain criteria. Now that we've laid the foundation of NumPy concepts, it's time for you to put your skills to the test. In the highlighted code section, we've defined a matrix representing daily temperatures. Your challenge is to count the number of days where the temperature exceeds 22 degrees. Share your code solutions and the count of days in the comments below. To facilitate seamless data storage and retrieval, NumPy provides functionality for file input and output. In this example, we begin by creating a 2D array using the np.array function. The array is then saved to a file named array.npy using the np.save function. This file format preserves the structure and content of the array efficiently. The next step involves loading the array back into a variable named loaded_arr using the np.load function. Thank you for joining us in this tutorial. If you have any questions, feel free to leave a comment. Don't forget to like and subscribe to our channel. You can find code examples on our GitHub page. Stay tuned for future tutorials, and we'll see you in the next video.